fractional exponents. Fractional means fraction. This whole unit, actually, I guess I should say this. I'm sorry. It's no calculator allowed. So no calculator for the whole unit. You actually won't really need it a lot because what we're going to be working on next week is we're going to be doing a lot of stuff with fractions, but it will also involve a lot of factoring. So simplifying things, understanding how fractional exponents and different things work will be helpful for what we're going to be doing. And then you're going to do this all the time in calculus. So super important. Let's fill in some boxes here. We're going to discover a pattern. 5 times 5 equals 25. There you go. So 5 is the square root. There you go. I didn't trick you there. So 5 is the square root of 25. 10 times 10 is 100. So 10 is the, again, square root. Nothing you don't know already. So if I have x times x, that equals x squared. So x is the square root of x squared. All right, now we're going to start to see a pattern here. X to the third times x to the third is x to the sixth. Right, you add the exponents. So x to the third is the square root of x to the sixth. And finally, x to the ninth times x to the ninth is x to the, right? So x to the ninth is the square root of x to the 18th. What do you notice about the pattern here? Yeah, the square root, the exponent there is half of the one you took the square root of. So that's going to actually help us because, so if I ask you to find the square root of x to the 10th, what would you say? X to the 5th. It's half of that. Now the reason that works, we'll write the rule here in a second, is because of this little thing I'm going to show you. If I have to fill in the little boxes this time to get x to the first, what exponents would you put on those x's? 1/2 plus 1/2. So x to the 1/2 times x to the 1/2, it's a teeny tiny box, I'm sorry, equals x to the first. So x to the 1/2 is the square root of x. Right? So here, let me rewrite it this way. X to the 1/2 is equal to the square root of x. So it looks like the square root can be written as a fractional exponent. Now, if you're trying to find the square root of an exponent, we can write it this way. The square root of a power is half of that power. Right? Does that make sense? So the square root of x to the 30th would be x to the 15th. Right? You take half of the power to find its square root. But notice the rule that I just did over here. X to the 1/2 was equal to the square root of x. So let's explore that a little bit more. We have a, well, we're not going to the chart. I forgot about this part, but we can do this. 16 to the 1/2, they rewrote it this way. And I'll talk about the pattern in a second here. It's the square root of 16. Okay? So what would be 16 to the 1/2 equal to? 4. All right, so notice here, where did the denominator of that fractional exponent go in the root? Was it the exponent or was it the root? It's the root. So then over here, if I have 27 to the 1/3, that 3, the denominator, is the root. So 27 to the 1/3 is the third root, or the cubed root of 27, which equals 3. Well, I'm showing you right now. Yes, so now from now on, we will expect you to know that if you have something to the 1/3, that's taking the cubed root of it.
But how do you know the cubed root of it off the top of your head?
Well, remember when we did all those know your powers back a long time ago? Just expect you to know some things, Grace. So if I have -8 to the 1/3 power, that's the cubed root of -8, which equals -2. You can take the cubed root of a negative. Because if I cube -2, that's -2 times -2 times -2, which is a negative.
So what if it was 4?
The fourth root of -16 would be 2i.
Okay.
So you would have an I there.
If it wasn't a square.
Yeah, if it was an even power on it. But since there's an odd root, you can have a negative.
Okay.
All right, and then 32 to the 1/5. Again, the 5th part is the denominator. So the 5th root of 32, yeah, right? Because 2 to the 5th equals 32. So if you undid that, the 5th root undoes to the 5th.
It's
magic.
4 times 6.
Yeah, now 2 to the 5th was on your know your power stuff earlier this year. All right, let's do the chart here. This is where I really want you to focus and stop playing on your phone, Bobby, and write things down. 2 ways we can write this, okay? X to the 1/2, we've said it's the square root. So you could write it, I'm going to put a little 2 here for a second. That's the square root of X. Now, we just said, do you really have to write the square root with the 2 there? No, you don't, but I'm doing it for example purposes. The denominator becomes the root, which means that the numerator actually becomes the power. Okay, so here it's just 1. So you could either write it as the square root of X parentheses to the first, or the square root of X and the first could go under the radical. Now, it just depends on the situation which one's going to be better. What if I have X to the 2/3? Which one is the root? The 3, the bottom, the denominator. So that's the cubed root of X. Now, you could either write it as the cubed root of X, the whole thing squared, right? The numerator stays high. Or you could write that as the cubed root of X squared. Either way, the squared is still an exponent, it just depends where you put it. And again, it doesn't truly matter. Some situations it just, you might need it. We'll see one later. All right, how do I write X to the 3/4? The 4th root to the 3rd, all to the 3rd, or you could do the 4th root of X to the 3rd. So again, I'm just going to point this out again. The 4 is the root, the denominator. The numerator here stayed as the power. Okay? So this is the rule. If I have m over n, a to the m over n, this was, I think, on the rule we had on your paper yesterday. The n is the root. The nth root of a raised to the m power, or again, you can put the m power with the a. Either one, those are equivalent statements. So what do you think happens when I have a negative exponent? That's a fraction. It goes in the denominator. So really it's just going to be 1 over the same thing. Because it would just move to the bottom. Now here's what we're going to do with this. We're going to simplify expressions right now. Okay? There'll be more in general, but for now we're going to flip our page and we're going to simplify things. So what we're doing, this will be its own quiz. So next week we'll have a quiz just on exponent rules, just like what you did yesterday. And we'll also have a quiz just on this kind of thing. How do I rewrite 7 to the 1/4 times 7 to the 1/2 with a simplified exponent? What do you have to do with these exponents if they have the same base? I'm only multiplied its power to a power. I don't have the same, I'm going to add them, right? I don't have power to a power. So in order to add 1/4 and 1/2, you have to have a common denominator. So I would change the 2. I would multiply by 2 over 2 to make that 2 over 4. So I'm going to rewrite this as 7 to the 1/4 times 7 to the 2/4. Now what's 1/4 plus 2/4? 3/4. And that's how we're going to leave our answer. It says the directions say to leave in exponential form. You don't have to write it as a root. Now you could, what would this be if you wrote it as a root? Not the cubed root, hold on, the denominator. This would be the 4th root of 7 cubed. You could write it like that, but we want the exponent. Okay, but just so you know, that's the 4th root of 7 cubed. Don't, if you're feeling a little lost here in a minute, don't freak out. Just keep following. It's weird. We haven't done this kind of thing before, so just stick with it. It'll get a little better. I have x to the 1/2 times x to the 3rd squared. So the first thing I think in this problem, it makes more sense to deal with this power first, rather than simplify in the parentheses. So here, what do I have to do with that 2? I have to make it go to both, right? So when I do 1/2, x to the 1/2 squared, I'm really multiplying 1/2 times 2. And what's 1/2 times 2? 1. All right, if I have 1/3 times 2, that's going to be x to the 2/3. Now again, just like the last problem, I need to add those exponents, but I can't add them like that. I have to create the 1 to have a denominator of 3. So what would that exponent be? X to the 3/3 times x to the 2/3. And when I add them up, I get x to the 5/3.
Look at me go.
There you go. Okay, so far? All right, these are not too bad to start with. So now I have 4 to the 5th times 3 to the 5th to the negative 1/5 power. Now, yes, we will have negatives, we will move them, but I think to start, it makes a little bit of sense to deal with the exponents first and then deal with the negative stuff. At least that's what I like to do. What is 5 times negative 1/5? Negative 5/5, which is negative 1. So it's 4 to the negative 1 power. Well, again, same thing. 5 times negative 1/5 is 3 to the negative 1 power. Now, what happens with those negatives? They go under the fraction. 1/4 to the 1st times 3 to the 1st. And all I have to do is simplify, which is 1/12. Yeah, that worked out okay. Let's try another one. 5/5 to the 1/3. Now, it's kind of hard to see, but that's your fraction line. What is the exponent on this top 5? 1. All right. What am I going to have to do with the 1 and the 1/3? Subtract them. Now, I know you can do that one in your head, but I'm going to rewrite it so we see it. I have to change this to have a common denominator to be 3/3. Well, what is 3/3 minus 1/3? 2/3. That's actually the whole thing. 5 to the 2/3. All right, these have all been fairly simple so far, right? Nothing too horribly complicated. Then I get something like this. I have the square root of x over x squared to the negative 2. This is where knowing your rational fraction exponents comes to help you, because otherwise you don't really know how you can simplify that. I want to rewrite inside the parentheses. Okay? What's the square root of x as an exponent? The x to the 1/2. Right? This has an invisible root of 2 out in front. Then that's x to the 1/2 over x squared to the negative 2 power. Now, for this one, I still think it makes more sense to multiply our exponents here by negative 2 before I simplify anymore. So here I'll have 1/2 times negative 2. Negative 2/2, which is negative 1. Okay, and then what's negative 2 times, I'm sorry, 2 times negative 2? Negative 4. What do you want to do next? There's a couple ways you can go. What do you want to do? Flip them. They're both negative. Flip their location. X to the 4th over x to the 1st. And now you subtract 4 minus 1 is x to the 3rd. Look how pretty that turned out. Kind of nice, right? A little bit? No? Maybe? Kind of? Alright, there's that. Ooh, this one's fun too. Cubed root of x squared. Let's rewrite that. How do I rewrite the cubed root of x squared with a fractional exponent?
X to the 2/3.
X to the 2/3. The exponent stays high, the root becomes the denominator. Well, how do I then rewrite 6th root of x to the 4th? Well, it is going to be, but first rewrite it. X to the 4th, 6. But, yeah, we're going to have to add those anyways, so why don't I simplify this 4/6 to be 2/3? All right, what do you get when you add them up? X to the 4/3 to the negative 3. What am I going to do with these powers to a power? Multiply. So you have to know what is 4/3 times negative 3. Negative 12/3, which is negative 4. And I have a negative exponent, so that's now 1 over x to the 4. So these are not necessarily hard, but you can't rush, right? You have to take your time and think about the parts. We're going to do 2 more. Okay, I'm going to skip one. Actually, we're going to do 1 more. I'm going to skip this one for now. Let's go to 8. This one looks fun. Doesn't it? Yeah. I mean, come on, look at that. What should I do?
Not do it.
We should do it. I skipped another one. We're going to do this one. I would distribute the part. Guys, pay attention to this one, please. Let's distribute. I will have x to the 1/4. It's actually going to turn out really nicely. Times y to the 1/4. Then over on this one, I'm going to distribute the 1/2. What's 2 times 1/2? 1. X to the first, y to the first. And then I'm going to have my denominator. Again, I distribute the exponent. I have 2 times 3/4. 6/4. And I'm actually going to leave it as 6/4. Can anyone anticipate why? What's the denominator up here? 4. We're going to need a common denominator. So let's leave it as 6/4. All right, and then that'll be y to the 3/4. All right, now everything almost has a 4 as the denominator except the ones. How should I change these? 4 over 4. All right, now all I have to do is add and subtract things, and we're good to go. So let's deal with the numerator first. X to the 1/4 and x to the 4/4. X to the 5/4. Okay. And then I'll have y to the 1/4 and y to the 4/4. Yep, with a y. And then my denominator stays the same so far. X to the 6/4, bless you, and y to the 3/4. Okay, so what do I do with the x's here? Subtract them. What's 5/4 minus 6/4? Negative 1/4. And y, 5/4 minus 3/4? 2/4. Yeah. Well, what's 2/4? 1/2. X to the negative 1/4. Y to the half. Who has to move? Who's unhappy? The x's. So you have y to the half over x to the 1/4. That is your answer. That worked out so nicely. Aren't those fun?
I like it. It's not bad.
You just have to take your time. You really do. Yeah. If you don't know where to start, get rid of the parentheses. Start with getting rid of the parentheses. So there is a little bit of practice here. Not a lot. If you flip over to the back page, I put the answers on the back. I know